Hello and welcome to the Data Center Cooling channel. My name is Kat Sullivan. I'm a channel manager here at DCD. And today we're going to be talking about managing data center cooling resources and performance at the water energy nexus. We're very excited to be partnering with Madison Air for this episode. So I'm even more excited to welcome Jill Wyant, President and CEO of Madison Air. Hi, Jill. How are you?
Good afternoon, Kat. I'm well. Great to see you. Thanks for the invitation.
It's great to have you join us. And we also have Jay Park, Chief Development Officer and founder of Digital Edge. Hi, Jay. How are you?
Fine. Thank you. Thank you for inviting me here.
It's really great to be speaking to both of you. There's a lot of different things that we want to talk about and we want to cover. So let's just jump straight in. We have covered AI in a myriad of different ways on this channel and across the DCD platform. But given the rapid advancements that we're seeing with AI and other technologies, data centers have to align with immediate need, with long-term infrastructure planning, with different challenges and different advancements that are happening at the moment. So how are operators balancing the demand of cutting edge technology while also ensuring that their facilities are remaining viable and adaptable over the next 30 years or so? Just to give a little bit of context, to paint a picture of what's happening right now. Jill, I'll come to you for this one.
Yeah, thank you, Kat. And it's a very interesting, perhaps one of the most urgent questions we face. And at Madison Air, through our Nortec data center cooling business, which has a combined over 350 combined years of manufacturing experience serving a number of mission critical industries, including the data center space, it's top of mind for us. And so given the pace at which the AI revolution is accelerating and an industry that is always, filled with change, it really makes the future across a 10, 20, 30-year timetable very challenging to predict. And so whenever I'm in a situation like that or we're advising customers, I always like to start with, well, what do we know, right? And we know that thermal density will get higher and that rack loads are going to get denser and that we're going to have more demand. And then when you put that in perspective, data centers, which today use about 1% of the world's electricity, there are estimates out there that suggest that could surge to 8% of global electricity demand by the year 2030. And astonishingly, that is the equivalent of the energy consumption of 1.2 billion average US homes. And according to the New York Times, they're projecting that as early as 2027, just a couple short years away, AI servers could consume between 85 and more than 130 terawatt hours of electricity annually. And that is astonishingly similar to what Argentina, the Netherlands, and Sweden each use in a year.
Wow.
And so here you are with those incredible demands in the backdrop in these mega mission critical environments that are data centers today. And so in my mind, there are really two considerations when you're thinking about planning across a multi-year time frame. The first is resource constraints. We talk about the electricity demands. And the second is really solutions that are flexible enough to ebb and flow and change on fixed infrastructure as those resource constraints evolve. And so when you look at it that way, there's an organization called the Environmental Research Letters that published a study that estimated that 1 out of 5 data centers relies on a watershed that is moderately or highly stressed, and that nearly half of data centers, at least partly, rely on power plants in very water-stressed regions. And this is what we mean when we talk about the water energy nexus. Electricity needs water to be generated, and typically when you're using water in an industrial application, it consumes electricity because you're heating it up, cooling it down, or moving it around. So this kind of resource future-proofing is vitally essential for data centers. And I think what Jay and I are excited to talk about today is how innovation and partnership are key to solving that over multi-year timeframes.
Yeah, and especially, I think, and we will focus on this in a little bit more detail later on in this conversation, those you mentioned resource consumption, you mentioned stressed areas as far as resources. let's pause that for now, because I do think we need to focus on that in a little bit. But just to take a step back and talk a little bit about AI's impact overall on all of the challenges that we're going to talk about today. AI has amplified a need for effective cooling. As AI chipsets generating greater heat loads, liquid cooling has sort of come in and has shown itself capable of carrying far more heat than air, and is becoming more of a default solution for these higher density environments. So Jay, if I could maybe come to you, sort of reflecting on everything that's happened over the last year or so, what are the key benefits of liquid cooling? What are some of the challenges that operators are facing in making this transition and also decision to make the transition towards liquid cooling?
Thank you, Kat. So I will even go back further than just 2 years, right? If you look at data center, the whole industry really erupted back in dot-com days, 1999. So those days, the rack density was somewhere between even 1 kW or 2 kW per cap. And then we're creeping up, and up until right before the AI, the servers come online, the rack density was somewhere between 6 to 8 kW per rack. And all of a sudden, just the past 2 years, this AI servers came on board, and then density went from 6 to 8 all the way up to now 40. Okay, and then even worse, now it's not even 40 now. It's like over 100 kW per cap. So when you look at this, right, and then and I'll just demonstrate it. When you have a fire and like a little match, right, you can easily blow it, okay, and you can put that fire out. When you have a forest fire, when you blow, it doesn't work, right? So we somehow this industry just skipped a major. It didn't even go from 40 to 50 to 60 like that. It just jumped from 40 to 100, right? So the air cooling, the technology is no longer valid, in my opinion. Okay, so in order to put this heat out, take this heat away, you need a liquid cooling. So that's given, right? So the good news is that the water temperature doesn't have to be that super cold, right? So when you think about like when you have a hot rod, hot heaty rod, and then you dip it into a warm water, you'll cool it. You can also put it in the cold water. You can also cool it, right? So the liquid cooling is the solution. However, we can actually raise that liquid water temperature to better manage and better resolve this the heat, the server heat issues, right? So so I'm really excited about this partnering up with the Nortec is because we have worked with Nortec way back. This is probably I'll just guess maybe about 8 years ago. We have worked, with Nortec came to me and said, "Hey, I have this sort of idea and technology. How can we use it?" Right. So I got excited because saving water is just, like what Jill mentioned, we will need a ton of water to generate electricity, right? So if we can save 30 to 40% of the water, that's huge, right? The challenge part is this, and this is going to be it's going to be a sort of ongoing kind of a discussion, but industry has not set a standard for how the server, the liquid cooled distribution is concerned. So there are some companies are dealing with the trying to make a PG25 as a standard, and some are some will have a just a direct water. So for data center, if we are in if one data center will have to host 2 or 3 different or many different customers, and they have their own cooling sort of technique or the strategy, then satisfying each one of those customers will be challenging, because you will have to do a lot of mixing, and then you'll have to add a valve. When you add a valves and whatnot, it becomes, you also have to deal with a single point of failure. So then you have to add a redundancy. So it gets quite complex, right? So
Yeah.
those are the kind of challenges that I've seen.
And if you don't mind, I'm just going to stick with you for a little bit, because moving slightly, I guess, sideways from the standards conversation into the different metrics that are being used, and that have sort of consistently been used for the different technologies that we've used so far. Let's talk about power usage effectiveness, for example.
Mm-hmm.
So PUE is critical, and is very impactful for how we view a data center's efficiency. PUE ratios have been a bit stagnant, despite all of the advancements surrounding them. AI has very much exacerbated this issue, with chipsets requiring higher electrical density, increasing power, increasing cooling demands. Liquid cooling very much proving itself more effective than air. Also, one of the benefits that most companies will emphasize is liquid cooling will also offer a path to an improved PUE. Now, what are some of the best practices that you're seeing at the moment when it comes to maintaining and improving PUE? Because is there a path? Is there a way to make sure and ensure that you will have an improved PUE? Is it something that will happen because once you transition to liquids, that's a given? Or is it something a little bit more technical that we need to be aware of?
So I'll share the good news first, right? The good news is that if we deploy liquid cooling, right, if you take that heat right out of that source, in this case, at the chip level, that is the most efficient way of removing heat. So if we deploy a liquid cooling, I'm positive that we can lower the PUE, just because we don't even need to run the chillers, depending on the AI server operating parameter. So if we don't even have to run a chiller, I mean, obviously the mechanical load power is going to drop, so that will improve PUE drastically. So currently, if you look at Asia market that I'm working in that region, the Asia the data center average PUE is 1.6. Right? So, I mean, as you guys know, we actually share this data with the public. We released this news, and Manila data center, we deployed SPLC, the Nortex SPLC, and we are able to obtain 1.193. So it's far below the average number, but I mean, you can get quite low PUE these days by using a chiller and whatnot. But if you don't have to run the chillers, you can further bring that PUE down. So I see this as a great opportunity for the industry, because quite honestly, the challenging part is not the technology side, is the changing our mindset, right? It's our mindset is that to adapt that, have that attitude of no pain, no gain, right? No industry, no leaders who want to change the design or the infrastructure, and they kind of wait. They're waiting and everything. But we've been working with the Nortec about 8 years ago. We developed this product. We launched it in our data center. I have a data center that has been operating for almost 2 years, and it's just we don't really have any issues. So this is why I wanted to share this good news with you guys.
Brilliant. And I'd like to talk a little bit about the business side of things. And obviously, Jill, and I'm sure that you can speak from Madison Air's point of view, and sort of the partnership that Jay's talking about with Nortec here is incredibly impactful. And one of the parts of the conversation that we've not necessarily touched upon so far is sustainability. Now, this is seen as an integral but separate concern when it comes to business growth, when it comes to risk management. We are part of a very risk-averse industry. How do you integrate sustainability into overall business strategy? How do you make sure that it is contributing to rather than detracting from these operational objectives?
Yeah, and I think it's a great question. And the partnership that Jay referenced is an example of a number of relationships we have with frankly, some of the biggest companies in the world, including technology companies, whether they be hyperscalers or co-locators and the like. And all of them, I mean, these are large, very forward-looking companies, have sustainability goals that they're committed to around reducing use of resources like water or carbon generation or amping up use of renewable energy. And I think the thing we're encouraged by is, there is this alignment of sustainable use, effective use of resources in alignment with business goals, right? Because at the end of the day, no matter how supercharged some of these words are, it's really about balancing business growth and share gain and success with a resilient business model, right? And so that's where companies and leaders like Jay and Digital Edge and others align business goals with sustainability goals and are really seeking, in the absence of standards, like he mentioned, to make the no regrets moves that are great business decisions on their face, because nobody's going to go throw good money after bad. And so, but really at the end of the day, these are companies that think about protecting their license to operate, which is key to running a viable business. And so I see 2 or 3 main trends that I would offer up today. The first, in terms of integrating sustainability goals and profitable business strategies. And the first is, rethinking our traditional financial modeling tools, CapEx decisions, which clearly large data centers are big capital expenditure decisions. And so a lot of the companies we work with have begun to put a real price on things like water and energy availability, because it's ironic in that these are local problems, and oftentimes where energy is the most constrained or water is the most scarce, those resources are ironically the cheapest.
Yeah.
And so they're starting to price the risk of water shortages or power availability challenges into their long-term modeling, at least to have sort of a 2 range of scenario outcomes. So the first is to rethink your CapEx to account for the underpricing of scarce resources that I think is a reality today. The second is, bring your regulatory team in on a project by project basis, right? And so those of us in the HVAC industry, and to some extent this impacted data centers, we know all about US EPA and the migration away from refrigerants with, global warming potential. So the move to lower GWP refrigerants. Of course, forever chemicals is something in the eye of regulators globally, and we all want to do the right, responsible thing there. And even watershed management. Here in the US, in boardrooms across the country, every big resource-consuming company's board is talking about, being responsible users of local water rights. And then the last thing I would say, and this is where, Jay and I can share some examples, is really we've got to innovate. And so while recognizing that these are mission critical, huge operations at scale where the cost of failure is incredibly high, how do we have the kind of partnerships across the value chain? So, designers, engineers, colos, hyperscalers, members of the supply chain, service providers, and the like, to ensure that we're forging new partnerships to innovate and experiment with technology that can solve some of our challenges at a small scale in the hopes of, ramping it up to larger scale over time.
Fantastic. I do want to take a step back, if it's okay with you, because Jill, you were talking about the water energy nexus earlier, and it is part of today's sort of the title of today's conversation. Data centers are not only consuming vast amounts of energy, but also significant amounts of water. The water energy nexus that you talked us through is a crucial topic, particularly in regions where that are facing water scarcity. Many data centers are located in water-stressed regions, and I do want to touch upon that in a bit more detail in a second. But Jay, if you don't mind, I'll come to you for this one, but how do you see data centers managing the trade-off between energy efficiency and water consumption, especially in areas where water is already a stressed resource?
So I'll start with by saying the energy efficiency is directly related with the water consumption. Okay, according to IEEE, the amount of water is needed to generate 1 kilowatt hour of power is somewhere between 8 to 12 gallons of water. Okay, so if you just build a 50 megawatt data center, it's a very small scale these days. Everybody's building 100, even you probably heard some 1 gigawatt data center campus. So, but I'm just going to take a 50 watt, very small, it's big, but now these days it's small. 50 megawatt data center, if you do the math, right, there's 87, 60 hours a year. And if you just lower the PUE by 0.1, okay, now we're going back. You got to look at this whole holistic view of this power is being generated and to all the way down to and how the power is used, right? So from power plant to server level. So you can't ignore this power plant side, right? So this is how much water do we need to generate to support this 50 megawatt data center. If you do that math, and if you just say it lower the PUE by 0.1, you'll be roughly, it's about 500 Olympic-sized swimming pool water savings per year. Now, if you drop this by 0.2, it's 1,000, folks. This is, if you just imagine putting a 500 Olympic-sized swimming pool side by side, it'll look like a gigantic lake, right? Mm-hmm. So this kind of water that we're using, we cannot ignore, right? So so at DE, our design standard is we're not going to go above 1.25 PUE. They are directly related. Now, that's at the power plant side. Now we'll talk about the data center level side. So we have to deploy a very innovative technology like what you just mentioned. And, for SPLC, we are starting, we're gathering data, but we anticipate to save roughly, this is a hot and humid climate area. It's not, free cooling area up in North side. We're talking about, the Indonesia. We're talking about, Philippines, where 24/7, it is hot and humid, and we're able to save roughly 35, even sometimes, some areas we can save up to like 40% of the water. So it is a gigantic. We have to do our part. Power plant has to do their part, and this is like it's not a one person's a game. It's actually we all have to be together and do our part. Then we can actually save water, right? So.
Yeah, no, but absolutely. And I think to your point, Jill, if I could just quickly come to you for a comment, because you talk through the business growth strategies and sustainability, but how do you reconcile the growing energy and water consumption of data centers with those corporate sustainability goals? What are some of the strategies that you've found most effective?
Yeah, well, I think when you live in uncertain times, like we're talking about today, flexibility is key. And it is a key element of a no regrets move strategy and can be your biggest asset in times like this. And it leads to what I think Jay articulated well, which is small improvements compounded over time make a huge impact, like literally hundreds and thousands of swimming pools full of saved water, which are, and when 1 in 5 data centers is in a water stressed region, that's really important. Mm-hmm. And so for us, and I can share an example. We've alluded to the work that we did with Digital Edge. So we know that liquid cooling is the answer as these chips get more powerful and there's more, thermal heat coming out of data centers. And so at Nortech Data Center Cooling, our State Point hybrid cooling plant is the flexible technology that Jay has been referring to that allows you to get in front of these resource constraints without sacrificing optimal data center performance. And so this product, the StatePoint Hybrid Cooling Plant, can operate both as an evaporative fluid cooler and a dry cooler all in one unit. And it really does that by utilizing free cooling and ambient outdoor air. And it does this without complicated mechanics or use of refrigerant-based cooling. And so Jay mentioned or referred to his Manila data center, where he deployed, was a very early adopter, which many tech companies have done since then, a user of StatePoint, where energy savings were 20%, and he mentioned the delta in PUE. And they have achieved 35 to 50% water savings at their Manila data center, where the local temperature and humidity of the environment is very demanding. And as a result, that data center earned an award as the most innovative in energy efficiency throughout all of APAC. And so what technologies like the StatePoint Hybrid Cooling Plant do is they move water and energy from this either or conversation, like you can only have one, you can't have optimization across both, into really a yes and conversation, because we have technology that can flex between using water or using energy based upon local environmental conditions, desired data center performance levels, and ultimately your sustainability goals.
Yeah.
So it's this kind of, and by the way, they deliver a good, cost point, because everybody's under pressure to do more with less. And so I think it's a great example of strong partnerships and technology making water energy nexus, transforming it from an either or to a yes and in the world we're living in.
Yeah, and strong partnerships is definitely something that is coming across in this conversation, but we're seeing more in the industry as well. Jill, I want to talk about something that you've mentioned a few times now is the local problems. And with Jay, we touched upon the actual regional stresses that are happening at the moment. So and Jay, I'll come to you for this one, because how do these regional differences in water and energy availability impact data center operations? Are there any regulatory trends, requirements, both at the local and federal levels, that you're seeing or foresee that might shape the future of water and energy management in the industry?
So I'm not going to lie, right? The data center size is getting bigger and bigger, right?
Yeah.
So getting power and water is very challenging. It's because the amount is just so big, and nobody wants a high voltage line behind their house and stuff like that. But finding a renewable energy is even harder, right? So, I'll push back on some of the politicians here. A lot of people think that we can solve this issue with solar energy, wind power. I'm an electrical engineer. I've been in the industry for 35 years, okay, building all kinds of high-tech facilities. Been in the data center market since 1999. I'm going to tell you, the solar and wind is not going to solve this growth, period. We need a new source of energy. We need a government, definitely a government to participate in many areas. They need to get involved with how data center is designed, and they have to understand how the servers are operating, at what temperature they can actually sustain. They need to do their homework, okay? And then perhaps mandate some, minimum requirements. All the data center has to meet 1.3 or 1.35 at minimum, okay? Maybe deploying somehow more renewable energy. Like, if they think they can support with a solar system, well, let's, do something and do more of that. Don't push all this responsibility to the users, right? Well, again, I'm big on this teamwork, right? And maybe government can provide some tax incentives or some kind of a credit so that people can actually procure this energy, and change some of the power that we think is very dangerous, such as nuclear power or geothermal power, or things like that. And I think the government needs to figure this thing out to run these power plants safer. And because I still believe those are a very clean energy. But obviously, if we don't know how to take care of the nuclear waste, or throw back all that water back into the earth, under the ground after you pull that geothermal steam, we have to figure this thing out. But yeah, we need government's involvement. So with everybody's effort, involvement, I think we can win to solve this issue.
So, other than government involvement, is there currently, in your opinion, is there a way that we can future-proof facilities at this point? I mean, as much as I really do appreciate your point on wind and solar, for example, the phrase that keeps getting thrown out on this conversation is the wind doesn't always blow, the sun doesn't always shine, etc. There are many changing environmental conditions. There are many different technological advancements that are very much shaping what we have to prepare for. So how are you actually working on strategies to future-proof, to make sure that you are remaining adaptable over time? And also, what are some of the key challenges that you're seeing when implementing these strategies?
So, number one, stay with the liquid cooling system, because density is not going to get lower. It's just going to go, hopefully we'll stay there for a long time, but, it's not going to come down. So stay with the liquid cooling system. And because right now, we think we can operate this, cool this AI servers with, condenser water or SPLC water alone, right, without running the chiller. So, but you don't know what's going to change it in the future. So if this AI server operating temperature drops, we will need a colder water. Okay, so if you want to do that, then you need to make some room, make some provisions to add a larger chiller in the future, so that you can actually use the data center for a long time. And the very one thing that people tend to sort of miss this is that you don't want to be short of white. Okay, so what that means is that you want to make the building envelope a little bit bigger, because building envelope is much cheaper than MEP cost. So build that thing and have some rooms, so if and when it's needed, that you have a room to augment the data center. So those are the changes that I personally like to make, because bringing more power into the building, that is not likely that is possible, because you have to increase the size of overhead conductors, the utility substation. There's a lot of things that you have to do. So, but those are the areas that I would do to sustain our future data center.
Sustaining the future of the data center is definitely something that I think is a great way to sort of phrase this as we wrap up this episode. Jill, I mean, when we talk about sustaining the future of the data center, future-proofing the data center, what are some of the big innovations in data center cooling that we should be keeping an eye on? How are operators preparing for these changes now? What do you think the biggest focus in the next 12 months is going to be?
Yeah, and I think in terms of evolving trends and innovations in the data center industry, and Jay said it, like, these are not organizations that are standing still. I live in Minneapolis, Minnesota, which is in the Saudi Arabia of wind energy, in the center of the United States, and we live very proximate to the Great Lakes. So, we're very fortunate. That said, as Jay meant, wind has its challenges, and at the end of the day, we need breakthroughs in battery storage for clean energy to serve, heavy industry and industries that demand as much power as this one does, for that to be feasible. But, customers aren't standing still, right? And so as I think about what the folks we're privileged to partner with and serve are looking at, first, it's as I said, regulatory activity, and thinking, not just on a PowerPoint page, but bringing your regulatory team into your planning around. We've seen it, global warming potential refrigerants and the migration to, lower GWP refrigerants, forever chemicals, and the impact that may or may not have on things like immersion cooling as data centers get larger and grow, the campuses get bigger. And then we also talked about watersheds. Like, are you is your data center one of 5 in a water-stressed region? And if so, how are you partnered with that community before you have a problem that could impair your service and impact your brand to get out in front of that issue? Second is, trend is obviously liquid cooling, and I think Jay did, just as he always does, such a marvelous job of articulating that and really finding partnerships across your value chain of people who are going to think ahead with you. Liquid cooling solutions aren't something you're looking at a catalog to order today. These are really bespoke technologies, like we started 8 years ago with Jay, who was a forward thinker and a visionary, and now that technology is at scale. So the leading lights are really looking ahead to what is the first of its kind technology in liquid cooling that I want to partner up to develop. And then lastly, and again, echoes of this in Jay's comments, size. So, some time ago, a gigawatt data center was just like blow your mind, unimaginable. Well, we all know, we have some talk of future sites that'll scale up to 5 gigawatts. And so this requires technology that can handle the demands of a mega facility like that one, but also thinking through how do we help you deliver high capacity cooling solutions with the smallest footprint possible, such that, as Jay said, you have time to grow. And so those are some of the trends we're looking at. And I think it requires close, investment by all of us and closer, tighter, more collaborative, partnership and teamwork across the value chain than, frankly, many of us have historically been used to or comfortable with. That's where the answer lies.
Fantastic. Look, I'm really, really sorry that we are running out of time so quickly. I do hope that we can have you join us again very soon so we can continue this conversation. Thank you so much to Madison Air for partnering with us on this episode. I know you guys also did a white paper very recently with us on this very topic. So to our viewers, if you haven't already checked out the resources below this episode, please do that now. And I'm sure if you have any questions, Jill and Jay will be more than happy for you to reach out to them and carry on this conversation offline. This episode also will be available on demand very shortly. So if you've missed anything, you can go back and look it over and listen to it again. And make sure to tune in soon for the next episode of this broadcast. But for now, Jill, Jay, thank you so much for sharing your insights with us today.